Hello friends, and welcome to this new video of the data science and machine learning course. In last video we have seen the concepts of natural language processing. So many common and core concepts that we need to understand that we have learned in the last video. Now in this video I am going to show you how do you make the combinations of natural language processing and the machine learning techniques, data science techniques then. This is a common and simple example I have taken, so it can be considered as a small mini project also. What different things you need to look for when you're going to use the data which is in non-structured format, that I'm going to show in this particular project first. Okay, so there is a very interesting file already present as a default data sets in many of the data repositories, and that repository is called as SMS spam collection. It contains the various SMS which are spam or which are not spam. I'll just show you the data set first, and then we'll go for understanding and using this. Let's see. So I'm opening this particular file in my notepad, SMS spam collection. Check it out. Okay, this is available on the UCI machine learning repository as well as on GitHub also. It's available. If you search in Google, then also you can easily find this repository. This data set is available over there. Now what data set contains? See, the first column is containing the information about the message, information which whether the message is spam or not spam. Ham means not spam and spam means it's a spam. Okay, so and check it out. So lot many messages are there. This message are received in the mailbox. See this, thousands of messages are present over there, and we're going to make use of these particular messages to classify them spam or not spam. Check it out. So some of the spam messages, you just can check it. Okay, the important thing here, two things are there that you need to remember. There is no any column name present above, and the category, that is class of the message, is the first column, and after that you can find a tab present there. Okay, there's a tab there. I'll just search it. Okay, so if you search the tabs /t, check it out. Okay, so these are the tabs present here. So after the spam or ham name, there is a tab present, not exactly a comma present there, or not semicolon, not a space. We have a tab. See, these tabs are highlighted when I search in my editor there. So it means that the separator is a tab. Nowhere tab is present except this particular location on that single line. And after that we are having a statement, which statement is actually the non-structured statement, which is lot many single line, multi-line, single words or multi words, or different kind of characters which are present inside it. Now it means that this data is non-structured. So in order to handle the non-structured data, we need to make sure that we have to make it structured, and then only the machine learning algorithms can be applied to them, and we can easily identify the or easily create the classification algorithm for this kind of the data here. And then at the end I am going to show you how exactly the algorithm can predict whether the new message entered is spam or not spam. Okay, so let's see. Here in it I am going to make combinations of natural language processing and the machine learning. So let's import all of our packages. So first of all I am importing NLTK. NLTK is our natural language toolkit, then pandas, then RE for regular expression. I'm going to use it, and one more I'm using from sklearn.featureextraction.text. I'm importing one class called as tfidf vectorizer. Okay, let's use this very interesting and important class in the natural language processing, which we are going to make use for extraction of the text. Okay, so that's what the use is. Then importing string also. String contains a string. I'm specially using for identification of punctuation marks. I want to find the punctuation marks from the data, so the list of punctuation marks is stored inside the string package. Okay, and yes, after that I'm going to read this my file pd.read_csv. This is your SMS spam collection file I am reading, and as we have opened the data set, we have seen that this data set does not contain any column names. So I'm giving a column names to them. So first column name is label, that is your output variable is label, and second column is the body text, where actually the text is stored. And important factor here is that the separator inside the file is /t. It is not a comma, not a semicolon. Step is a separator over there. Okay, so after that the data is read, and after data is reading, I'm going to show you that data on the screen by the first 5 entries of it. Let's see how exactly data looks like. Yes, it's perfectly the data is read, and this is your body text which you are given the column name here, and first column name is the label separated by a tab. So we got this data in the form of a data frame. So you can see first 5 entries that this data frame carries are shown over here. Okay, now let's see how many number of entries are present. So a special function that we can make use for the respective series objects called as value counts. So in the label, so label is your output variable. So in this label, how many values belongs to a single class and how many belong to another class. So we can find with the help of the function called as value underscore counts. So here in it we are having 2 classes. As we have seen, 2 classes are there. Total messages, ham messages are 4825 and total spam messages are 747. Okay, so basically by this particular understanding we can find that this data is not having the similar kind of messages for classification. Okay, dissimilar messages are present. So ham are 4825 and spam are 747. So basically if you consider the principles of the machine learning, we need to resample this data and make both of this same. But in this particular program I'll be showing the concept without resampling. So without resampling we are going to make use of this, and then we'll see whether you are giving accurate results or not. If accurate results are not given, then resampling may be expected in this case. Okay, so total number of counts that we have seen by using the value underscore counts function. Now most important part is the pre-processing the data. Now pre-processing we need to look from different point of view. So here in this I have used multiple pre-processing things. Like first thing is that we need to remove the stop words from the given data, so that weightage to the particular sentence or weightage to the particular message will be perfectly identified. That is for stop words. One more thing that I need to remove the stem words also. Stem words we have seen the extra words connected to the dictionary words called as stem words. We can remove that stem words by using, I'm using a Porter steamer here to remove that stem words. Then one more function I have created here, which is count punct. It is used to count total number of punctuation marks in it. So how many punctuation marks the particular word carries, that I have given here. I'm going to find it. And then one more, we are using a function called as clean text. With the help of the clean text function, I am making it more clean. That for example, I am removing the punctuation marks from there, I am removing the stem words from there. Okay, so and then clean tokens are created by using the clean text here. After the text is cleaned, then only I am going to apply the second methodology of converting this data into the numerical format by vectorizing it. So let's see how to pre-process the data. So first of all, from NLT case corpus, I am extracting these stop words and storing all the stop words in the list of stop words here. Then one object of the Porter steamer I am creating here, nltk.porter steamer, which is used to remove the stem words. Fine. So let's see 2 functions which I have created here. So let's apply that and make use of these particular functions. The first function I am creating is count punctuation marks. So this count punctuation mark, count punct, is the function is to count total number of punctuation marks in the given text. How to do this one? So the text which is passed over here, okay, this text which is passed here, so I am counting it. How to do this? Let's see this for it. So here sum of, and then I have given one list by list comprehension, one for char in text if char in string dot punctuation. So how it is done? So for char in text, from this text one by one character is taken here. So first, second, third, character by character, and if that character is present in the list of punctuation marks, so if you print this string dot punctuation, it contains all the punctuation marks present on your keyboard and present in your dictionary. Okay, so or your grammar basically. Okay, if it is present there, so make it 1. Okay, so it will create wherever that character found as a punctuation mark, so that one will be stored also, 1 comma 1 comma 1 comma. So list of all the ones will be created whenever punctuation mark is matched. Okay, and after that I'm going to make a sum of all together. Okay, this is how the sum operation is done, and I will count total number of punctuation marks present over there. Okay, so total number of punctuation marks present over there, that I am going to make use of this. Okay, after that, so one more thing that we need to remember here is that here so I am not exactly returning the same count from here. I am returning count divided by length of text minus text dot count spaces. Okay, so this is a special formula I have created here. Total length of the text, okay, total means out of all the text, how many number of elements are count, means what's the percentage of elements are punctuation marks. Okay, that is identified here, and after that I have subtracted the total number of spaces from this. Spaces I am not going to consider that. Okay, so I am subtracting total number of spaces from there, and then returning that particular value out of it. So how return value is, therefore I am rounding it to 3 digits and into 100. So it will identify that how many percentage of characters are punctuation marks inside this particular sentence. Okay, that is found with the help of count punct function. Then to the original data I am applying 2 more columns. The first column is the body length. Okay, so length of the body, how many number of characters are present there, that we can find by using body length. And one more is there, it's called as punctuation percentages. So how much percentage of the data is actually the punctuation marks within that text, that will find with the help of this particular method. So body length is equal to data of body text that apply. So this body text I am applying a lambda function. So which one? See, lambda of x, length of x minus count the spaces. Okay, so total number of spaces are there, that will be subtracted, and all other elements length is applied to this particular body length column. So body length column will be created, which will contain total number of characters in that respective line, but it is not considered with the spaces. Okay, that's what the extra column I am adding. Now second method is punctuation percentages. So which function I have created here, this function I will be applying here. So data of body text dot apply lambda of x count punct. So whatever for every line, so line will be given here count punctuation, so it will count the punctuation marks and attach column by row by row to respective column here. So this punctuation percentage function will carry the total number of punctuation marks inside the respective text. Okay, that's what this statement is doing. And at last I am going to make use of a clean text function. So with the help of clean text function, a cleaned text will be created, and that we are going to return from this particular function. So here by this I am finding whether this particular word is not in punctuation marks. So word dot lower, make it lower function for word in text. If word is not in the punctuation marks, if it is not there, so that text are connected together with the help of this join method. So join is a special method that we can use along with an empty string to connect all these things together taken from the list. So they are stored here. Then from regular expression split, I am splitting this data into token format. Okay, after that the last step is most important part. Here is I am using a stemming. So here PS is a protostemous object, PS dot stem word. So if some stem words are present at the end of the respective word, I am removing them for words in tokens. If word not in stop words, okay, take that words without the stop words, remove the stop words, and then stem that word and store into text format. So after applying all this data, applying all these methodology of punctuation marks, word splitting, then my cleaned text will be returned with the help of this clean text function. So I am returning this clean text which I have passed. I am pre-processing it, returning a clean text from it, and without stop words, without punctuation marks, without spaces, without any special symbols, and without using any stop words. Okay, so that data is returned, which will contain the information that will be available for us to use in the further processing. So I have just executed these particular statements and now go to the train, test, split. Okay, so till this point we have done all the pre-processing of the data with the help of natural language processing techniques. Now after that, let's make splitting. So I'm importing train, test, split, and after that we know that now column is pre-processed. So if I print this, see, two columns we added here. Already two columns were present. Two columns present were label and body text, and two more column I have added, that is body length and punctuation marks. Out of all these four, three, that is body text, body length, and the punctuation percentage, these three columns I am storing into X, that is your input variable, and the output variable label I am storing in the Y. Okay, so X and Y are now separated. After this, I am going to make use of the train, test, split to separate this particular data. So X train, X test, Y train, Y test equal to train, test, split. X, Y trace size I am giving 20%, and then random state I am keeping as 0. Okay, let's see. From sklearn model selections, we have done the splitting of this particular data into the train, test format. Now before actually applying this data, see, data is still not containing the information which is numerical, because whatever algorithm you apply for machine learning, every algorithm is based on statistics and mathematics, so it needs the data in the form of numbers. So we need to vectorize this data. Vectorization is just to perform the operation to apply the weightage in terms of numbers to the respective text. That is what TF-IDF vectorizer will do for you. So here I am creating the object of this particular class. The class already imported from the sklearn's feature extraction text package. Okay, and analyzer I require. So which analyzer, which particular function? Analyzer is the function name by which the data will be taken. Means by applying this data, returning it, by clean text data will be taken. Okay, this is the way analyzer I am giving, and then TF-IDF vectorizer dot fit train body text. So only body text data is given there, and that data will be vectorized, and then it will be stored into this particular variable. Okay, that's what we have done over here. Okay, after that I'm going to apply the same transformation methodology to training data to body text, and same transformation methodology to testing data of body text. Okay, so that's what we are going to. So here I have fitted it, and then I am going to apply that to body text and body text for train and test separately. This can be done before train, test, split also, but after that also I have done, and with the help of that, this applied to body text and train. Okay, and after this I made the combination. So here we know the body length and punctuation marks, these two are the numerical columns. That's why this vectorization giving the numerical weightage is not applied to body length and punctuation marks there. Okay, that's why I have separately applied to body text, and then after it I am going to make the combinations of it. So by using pd.concat I am going to apply, connect them together. How to do this one? So from X train, body length and punctuation marks I have taken, then reset index. So remember, now after that the index will be changed, because extra columns will be connected to the body text, so their index will change. Okay, reset index, and what to apply? So this splitted data or the transformed data by vectorizer, that I am going to apply there. X is equal to 1, it means that it's added to the columns. Okay, and by using TF-ID.train to array, so it's converted to array format, and then they are added separately. Same is applied over here, and means these two columns are connected. Along with that, the transform columns are also present over there. These operations I have done. If I run this code, check it out, what exactly the vectorized data will carry. See this one. These two columns are present, body length and punctuation marks. They are already numerical columns. So you can see the punctuation percentages are actually identified, and this is vectorized data. You can check it out. Total vectorized data is present. It contains almost 7183 columns, and the data is converted in numerical format. Okay, this vectorized data is converted in numerical column all. So total almost more than 5000 rows and more than 7000 columns are present in this vectorized data, and data is perfectly formed down. Perfectly formed means it's perfectly a structured data with the numerical entries present inside it. So we have converted our data into the numerical format with the help of the natural language processing and the vectorization. Vectorization itself is a part of NLP, that we can consider here. Okay, so this all pre-processing is expected when you're going to have the data in the non-structured format. Now we are getting in structured format with the numerical entries present inside this, and now our data is ready for getting used by the different kind of classification algorithms. So here in this case I'm going to make use of random forest classifiers. We can make use of any other classifier also, but for practice I'm using random forest classifier. You can change it, you can try other classifiers also. So let's import the random forest classifier, and I'm importing accuracy score also, so we can make use of the score function to find how much accurately the model is classifying the spam and ham messages. So let's go for that. Let's create the object of random forest classifier. Number of trees I am keeping 150, random set equal to 0. RF model equal to rf.fit, so I am fitting the vectorized data, and y train I am not going to change, output variable y I am not going to change. Okay, so the object is created. Then I am going to use predict function to apply this data on the remaining data set, xtest vect and ypred I am generating out of it. Yes, so predicted the output, and after that I am going to make use of confusion matrix to and classification report. So all they are in the same function package here. I am importing confusion matrix now. Let's print the confusion matrix and check how accurately the classification system behaves now with 150 trees of random forest classifiers. Taking some time because data is huge, and even random forest classification system is also very complex than any other kind of algorithms there. So let's wait for that, whether it is creating a perfect classification model or not. Yes, check it out. So perfect. So this is what we can see here. 0 misclassifications are present. Okay, and here 24 misclassifications are there, but we can consider accuracy is good, and it's almost 97.84%. Yes, perfect classification mechanism is created, and accuracy is 97.84% that we have achieved from this particular classification algorithm here. If you print a classification report, okay, check this one. Yes, ham identification of ham is done 100% time, because recall is 100% and spam recalls is 0.85%. Above 80%, that's it can be considerable, but their score is also good. F1 score, that is 99% for ham and 92% for spam. Okay, so from out of 160 here 24 misclassifications are, that's why it is 85% accuracy that we have achieved from this particular mechanism. It means, so this is how we are going to make use of the classification algorithm and combining the natural language processing together. The most important thing is here is that, see, we have created the classifier, but how to do the predictions now? Can when a new message comes and you are going to make use of this message and perform the predictions, finding is whether it's spam or not spam. So let's do this one. I am having one more sample file with me, and on that sample file, so let's see this sample file. We have this sample file. Okay, let's check the, okay, yes, the sample file is present here, so let's try that. Check this. I'll open this sample file. It contains 3 messages only, new messages, and I just want to find what category of that messages are, whether this message is spam or not spam. Directly applying the classifier and doing the prediction is not possible. We have to work on all kind of pre-processing techniques that we have applied. You have to pre-process the data, and after pre-processing the whole data, then only it can be applied to the respective algorithm for prediction, and it will predict whether the message is spam or not spam. Let's see this. Okay, so 3 messages are present over here, and I need to read these 3 messages, and then I have to find what kind of message is this, whether this message is spam or not spam. So 3 messages are present over there in sample.csv file. Okay, so let's read this file. So I'll just open. Yes, now let's read it. Data is equal to p.read csv sample.csv, and I'm giving a name to it. See, one important thing that you have to remember here is that it does not contain the class. We have to predict the class of it. So only body text is present. So I'm reading it and giving the name to the column as body text separated by tab. Okay, data is read. Check this data. So if you print this data here, so let's take it. Yeah, this is the data present. Only the messages are present. Out of these 3 messages, which message is spam, which are not spam, that we have to identify it. Now while training the algorithm, we have pre-processed the data, we have applied all the natural language processing techniques there, and we have identified the results out of it. Now I want to do the same processing there. So what to do? So defined functions I'm using it. Body length column I have added, then punctuation marks, percentage column also I have added with the same function that we have chosen above. Okay, so let's do that's completed here. Okay, showing a warning. Okay, no problem. Okay, so that's added. Now after that, the vectorizer object which I have created, I'm using transform method to transform this data into the vectorized format. Check this. Okay, so data is something like this. Okay, which you are after adding the columns, and finally we are going to concatenate this body length, punctuation symbol, and then the set index, and data frame, new vector array. Okay, whatever we have done above, same technique I am applying here by creating a sample vectorizers. Check the sample vectorizer now. Exactly same method and mechanism is applied there, and then we have identified, we have pre-processed the data, we have transformed your data in the expected format by the random forest classifier there. Okay, so data is now available for us to use, and now the final step to predict which particular message is spam and which particular message is not spam. By using the predict function of your random forest model object, we're going to make use of pass the sample vectorized data as parameter to it, and then generate the results. Yes, check this. So first message is ham, second message is spam, and third message is ham. So out of three, second message is spam only, and first and last message is the ham. Ham means it is not actually a spam message. Check it out. I'll just open the data again. By reading this message, you can identify it's spam or not. See, this is a simple message, and this is also a simple message, but if you see this message, it's a spam message. I think I'm pleased to advise you following this entry web mobile number, you're awarded with this bonus prize, and call on this number something. Okay, so it's written and it's a spam message. So spam is identified perfectly after vectorization, and our algorithm is also behaving correctly. Okay, so this is how we are going to make use of the natural language processing technique plus the machine learning to generate a perfect result. Natural language processing techniques is also termed as the text analytics techniques. Many times, just like using this is one of the example which I have seen. Wherever the spoken languages are there, wherever the grammatically written languages are present, okay, wherever the voice data is present, okay, so there we are going to make use of these techniques, and after that only your algorithm can read the data, and then it can do a perfect prediction or perfect classification system to get worked on this data. One more thing to remember here is that English is the not only language which can be used for this operation. Other than English, whatever languages present in the world, or hundreds of languages, prime languages, can be used in natural language processing to do this kind of operations here. Okay, so this is how we are going to make a small mini project by which we can combine NLP and ML together and do the predictions. You can try by your own. For others, like Twitter sentiment analysis is very interesting project that we can try and identify how NLP can be beneficial for data science application design. Thank you. Thanks a lot.